Amy walked to school this morning, and then 15 minutes after she left, her brother Ben ran out the door to catch her. Ben's speed is twice Amy's speed. How many minutes did it take for Ben to catch Amy? Alright, well, we could use distance equals rate times time on this. Now we know something about the time, the fact that the delay between the time that Amy starts and Ben starts is just 15 minutes. But we don't know Amy's rate or Ben's rate, but we do know that Ben's rate is twice Amy's rate. So let's define some variables. So Amy's rate we'll just call rate A. Okay, that's Amy's rate. And let's call Ben's rate RB. Okay, that's Ben's rate. Okay, and we are also told that Ben's rate is twice Amy's rate. Alright, and when Ben catches Amy, they're going to be at the same position. Alright, so we want to find when Ben catches Amy. So we want their distance from home to be the same, okay, at the point when they meet each other. So let's take a look at first Ben's distance from home, okay, and let's just measure. Let's start measuring the time from the time he leaves home. So the distance he travels is just his rate times time, okay? And Amy has a 15-minute head start, okay? So her distance from home is equal to her rate times t plus 15, okay? So she's got a 15-minute head start. She's already been walking for 15 minutes. So the distance she traveled in that 15 minutes is her rate times 15. And then we can add the distance she travels over the time that Ben is running. Okay, so you can think of it that way. If we distribute this, this is the RA times T is the distance she travels after Ben starts out, and RA times 15 is the head start that she has. So it's the position she's at when Ben starts out. Alright, so we can just solve this equation, and we probably first of all want to substitute because we know that Ben's rate is twice Amy's rate, so we can just put 2RA in for RB. Okay, so then we have everything in terms of Amy's rate. And then, let's see, we can multiply through Amy's rate times time plus Amy's rate times 15. Okay, and now I'm seeing that we have a couple of terms here. This term and this term are just RA times T, or some constant times RA times T. Alright, so let's put all those terms together. I'm just going to subtract RA times T from both sides, so the equality still holds. And what we have over here is just RA times T. So if I have two of them and subtract one, then I have one left. So RA times T. And that's equal to Amy's rate times 15. And then assuming that Amy's rate's not 0, which means she's just standing at home and not going anywhere, we're going to assume she has positive rate. I can just divide both sides by Amy's rate. And we end up with T is equal to 15 minutes. Okay, it's in minutes because the other time that we used was also in minutes. Alright, so the time that it takes for Ben to catch Amy is 15 minutes, because after 15 minutes Ben and Amy will be at the same position. Their distance from home will be the same. Okay, so Ben catches Amy, and it makes sense if you think about it. Ben's traveling at twice the speed of Amy, and so for every unit of distance that Amy walks, Ben runs twice that. Okay, so one of those units of distance he's just keeping up with Amy, and then the other unit of distance he's making up the head start that she had. So it makes sense that, you know, since he has essentially, she has a 15-minute head start, that he's got to make up 15 minutes of her distance. The distance she travels in 15 minutes, he's got to make that up. And if it takes, if he's traveling at twice the speed, and he's covering twice the distance that Amy does in for every minute, then he's got to make up 15 minutes worth of her time, of her distance during that time. So it makes sense. So that's the answer. 15 minutes.